What's up? It's Swervo here with another video. In today's video, we're going to explore solving systems by graphing. We're going to look at these when the linear equations are given to us in some different ways. So if you have some scratch paper or graph paper, I encourage you to take it out. You might want to preemptively make a graph that can help you. So pause the video, do that, and we're gonna get started. All right, so for numbers 1 and 2, I have linear equations that are in slope-intercept form. So remember, we always are gonna start with our y-intercept. So if I'm looking at this first system of equations, the first equation has a y-intercept of 4. So I'm gonna go ahead and put that point down. And then I'm going to look at the slope. The slope is negative 5 over 3. So that means I go down 5 from my y-intercept and over 3. So my other point would be right here. And then I'm going to draw my line as best as I can. It's just hard. Okay, there we go. All right. Now for the second equation, I'll switch colors here. I'm going to do the same thing. Start with my y-intercept. So y-intercept is negative 2. Click on the y-axis, go down 2. And my slope is 1/3. So that means I go up 1 over 3. Up 1 over 3. Up 1 over 3. That would kind of be somewhere over here. And then I would draw that line, which will look roughly like that. And hopefully you guys can see that these two linear equations are going to intersect at a point, and that point where they intersect is our solution to the system. So that would be, if I write it as an ordered pair, which I'm going to want you guys to do, is going to be 3, negative 1. Alrighty, let's go on to number 2. It's going to be the same thing. I have two linear equations in slope-intercept form. Start with my y-intercept, negative 1. The slope here, remember, there's a 1 in front of that x. So 1, think of it as 1 over 1. So you go up 1 over 1, up 1 over 1. So here is my graph. I apologize, I'm not the best at drawing these sometimes. And then the second equation has a y-intercept of 4 and a slope of negative 2/3. So again, I've talked about this in class, but a lot of times that negative sign is just going to be in front of the fraction, and it might help you to interpret it as either in the numerator or the denominator. In this case, I stuck it in the numerator. So that helps me remember I go down 2 over 3 to the right. So down 2 over 3, down 2 and over 3 would put me around about there. And then let's see if I can draw this nicely. We can see that these two linear equations have a clear intersection right at that point, and that point is going to be 3, 2. Now I'm going to do something here that I didn't do in the first problem, which I'm going to check my solution. So remember, a point is an x and a y value. So to check our solution, we can plug in 2 for y and 3 for x into both of these equations up here, and if we get true statements, we know that we did it right. So if I plug it into this first equation, y equals x minus 1, so I'll plug 2 for y. So 2 equals 3 minus 1. You can kind of just look at that and tell that that is going to be true. 3 minus 1 is 2, so that works. And then the other one is 2 equals negative 2/3 times 3 plus 4. Now this one is a little, maybe harder to simplify, but we've talked about this in class. The 3's are going to cancel because I'm dividing by 3 and then multiplying by 3. So I would get 2 equals negative 2 plus 4, which is the same as like 4 minus 2, which is 2. So that confirms that this point is a solution to my system. All right, let's move down to number 3 and 4. Okay, now I'm going to show you 2 ways that you can do this. One is if I take these equations and I convert them to slope-intercept form. So if I look at this first equation, I'm going to put a little arrow here, and I'm going to solve for y. So this is a little tricky at first when you first see this, but I basically want to undo everything that is happening on this side except for y. So I see a positive 3x. I want to get rid of that. So I can't just erase it. I have to subtract it from both sides. And when I do that, I will get 2y equals negative 3x plus 4. And now I'm going to divide everything by 2. So that gets divided by 2, that gets divided by 2, and that gets divided by 2. So let's see here. This is going to be y equals negative 3 over 2 x plus 4 divided by 2 is 2. So this is going to tell me, well, this is now in slope-intercept form, so I can use it. 2 is the y-intercept. Plot that point. And the slope is negative 3 over 2. So I go down 3 to the right 2. Down 3 to the right 2. So this is going to be my graph. It'll look like that for the first equation. And now I can do the same thing for the second equation. So I will kind of go. Now I encourage you to try this on your own. Pause the video, see if you can take this second equation and solve for y. Okay, I hope you had a chance to try that on your own. So the first step, I'm going to get rid of, quote unquote, this positive x. So negative 2y equals negative x plus 4. The other way I tell students to think about this is if you want to move a term like positive x to the other side of an equal sign, you change the sign from positive to negative or negative to positive. So positive x became negative x when I moved it to the other side. Now the last step, divide by negative 2, everything. Divide by negative 2. So here I will get y equals, this is going to be negative divided by negative is positive, and there's like a 1 in front of this x. So this might be a little confusing, but it's going to be 1/2 x minus 2, because positive 4 divided by a negative is negative. So now I can go ahead and use this equation in slope-intercept form. My y-intercept is negative 2, and my slope is 1/2, which means I go up 1 over to the right 2. So this is going to be my second graph, and again we can see these are going to clearly intersect at the point 2 comma negative 1. We can check our answer again, which I will do. So again, a point is some x and y value that you can then plug into the original equations. So here, if I plug it into the first equation, I would get 3 times 2 plus 2 times negative 1, and it's supposed to equal 4. This is going to be 6. This is going to be minus 2. And yes, 6 minus 2 is 4, so that checked out. And then we can check the other one. Let me maybe pick this color. So it's going to be, I'm going to plug in 2 for x, minus 2 times y. I'm going to plug in negative 1 for y, and it equals 4. And let's quickly confirm this. So we get a 2. Negative 2 times negative 1 is positive 2. And that is confirmed. 2 plus 2 is 4. And we're done. Okay, now let me show us, let me actually think about this for 1 second. My other way, because of how this graph is, let's actually convert these to slope-intercept form as well. Maybe in the next video I will show you guys how to graph an equation in standard form just by checking for the x and y intercepts. Stay tuned for that. Right now we're going to do the same process. So I encourage you, pause the video, see if you can do this whole problem on your own. Alright, so I hope you had a chance to try that. We're going to go through it quickly here. So this will become negative 3y equals negative x minus 9. Again, I move the x to the other side. Don't forget to make it negative. And then divide everything by negative 3. So we get y equals, again, negative divided by negative is positive. There's kind of like a 1 in front of that. So it's going to be 1/3 x. And then negative 9 divided by negative 3 is positive 3. Now I'm going to just convert this before I graph. So this would become 3y equals negative x plus 3, divide everything by 3, you're going to get y equals, there's like a negative 1 there, negative 1 over 3x, 3 divided by 3 is 1, and now I'm going to graph. So I'm going to graph this one. Y-intercept is 3, slope is 1/3. Oops. Oh man. The hardest part for this is drawing. Okay, the other one has a y-intercept of 1 and a slope of negative 1/3. So I go down 1 over 3. Or, and I mentioned this in class, you can always interpret the slope instead of this as this. So what I'm saying is you can stick the negative in the numerator or the denominator, it doesn't matter. So if you think of it this way, you would go up 1 to the left 3, up 1 to the left 3, and when you graph that line, oh whoops, oh god, alright, well, good enough, pretend that was better. And we can tell where these points intersect. They intersect right at this point, which would be negative 3, comma 2. I'm going to save checking the work for you. I will leave that as an exercise for the reader, as they say. That's all for today. I will see you guys in the next video.